Word. There you go. So 9A deals with functions. And typically functions are what we call the building blocks of mathematical models. All right, so we'll look at a few definitions on this real quick. So basically a function describes how a dependent variable changes with respect to one or more independent variables. So it describes how a dependent variable changes with respect to one or more independent variables. And typically when there's only two variables, we often summarize them as an ordered pair with the independent variable first. So when there are only two variables, they are often summarized as an ordered pair with the independent variable first. So ordered pair, if you remember those in parentheses, back when y'all was doing this in math, you probably had an X and a Y. So here we actually call the X the independent variable. And then there's a comma, and then Y is what we call the dependent variable. So if I was going to use say a paycheck as a variable, my time for the hours that I worked, that would be my independent variable, because you can change the hours you work a week. You might work 30 hours one week, you might work 40 hours a week, and then you might even have overtime and work over 40 hours. So that's what you call an independent variable. The dependent variable would be the amount of my paychecks, because it depends on how many hours you work. Okay. So that's what they mean by a dependent variable, when something like your pay depends on another variable, such as time. All right, so the dependent variable is a function of the independent variable. So if X is the independent variable, and Y is the dependent variable, write the function as y equals f of x. And they use the f to just represent that it's a function. So what an x is, that's your independent variable. And then that y there would be your dependent variable. Okay, so they're just getting you used to notation on that page. All right, y'all. So we got 3 ways that we can represent a function. So this is 3 basic ways to represent a function. All right, so I'm gonna pull my camera down to catch this. All right, so 3 basic ways to represent a function. We can use a data table. All right, let me let one in real quick. So a data table, one that you might have seen for a data table could be a X and a Y table where you have X values and Y values. So that's one form of a data table. Second way I can represent a function is to draw a picture or graph. And we're really bigger on using graphs. So remember, a graph if you're looking at a graph, the horizontal axis is your x-axis. That's for your independent variable. And then the y-axis is what we called our dependent variable. So the amount of these y's depends on these x's, okay? And we're not going to draw lines or nothing. They just want you to see the basic ways that we can represent these functions. So then the third way is to write an equation or formula. So you might see equations like y equals mx plus b type stuff. That's the equation for a line. They might even use this f of x equals mx plus b. So they use f of x instead of y. A lot of times they'll do this notation if they want you to know what the variable is going to be, okay? All right, y'all, so let's turn the page. I'll give y'all a second to write that. All righty, so next we'll talk about domain and range. So let me push this back up. We'll say, so we're going to learn about domain and range. Domain so the domain is the set of values of the independent variable. Now let me let one in real quick. All right, so it's a set of values of the independent variable that both make sense and are of interest for the function. So if I was looking at a domain for my paycheck example I did earlier, remember the domain is the set of values of my independent variable. So the minimum number of hours I could work would be 0. And then let's say I might work up to a maximum on that. I'd probably put anywhere like 60, 70, or 80 hours. So my domain would be from 0 hours up to, let's say, 60 hours. Okay, so that's all the values that can be put into my function that would represent my independent variable. So the range is similar. It consists of the values of the dependent variable that correspond to the values in the domain. Okay, so I'm going to sort of show you an example going through these. And I'm going to use my paycheck example. So I'm going to start it out with the table because that was my first method was, remember, I could use a table or data table. So I'm not going to put every hour I could work, but if I work 0 hours, I'm going to get 0 pay. And let's just say I'm making $10 an hour. So if I make $10 an hour, if I work 10 hours, that would give me $100. And we'll do 20. If I did 20 hours, that would be 200. So let's go up to 40. And we're going to say this job, you cannot work any overtime, okay? So 40 would be the maximum hours I can work at this job. So 40 hours times 10 would give me $400 paycheck. So that's my data table. Now, if we was wanting to look at that on a graph, so there'd be my X's and my Y's. So my domain is going to go on the X-axis. I don't really need no negative numbers because I can't do negative time. So I'm not going to work with none of the negative side. X's are positive to the right side. So 0 would be in the middle. And then let's make this go by 10. So there's 10, 20, 30, and 40. So my domain can go from 0 hours if I don't work at all that week, up to 40 hours if I work all 5 of my days. Now notice the y-axis, we're going to have to number a little different because it starts at 0 and we got it going to 400. So here's 0 in the middle. And then we'll make this one go by 100 each time. So you got 100, 200, 300, and then 400. So that's what they're talking about. Your range is the numbers that will represent the value of the dependent variable. So my range can go anywhere from 0 up to 400, okay? So to plot your points, 0, 0 would be right there in the middle. Then I had, when X was 10, Y was 100. So you come over to 10 and then up to 100 for that point. Next, I had 20 and 200. So I go over to 20 and then it goes up to 200. Then I skipped a few, but my last one was 40 and 400. So go over to 40 and then you go up to 400 on your graph. So that would be the graphical method of this one. So here's your table, your graph. And remember, the third way was to represent it by a function. Okay. So we know that I said we made $10 an hour. And to figure out your paycheck, you take the number of hours you worked and multiply by your pay. So we get paid $10 an hour times how many hours we work. So our X's, which is our independent variable, is our hours that we work. Y is the dependent variable, and it's the amount of pay. So we've got our data table, our graph, and our equation or function, okay, or formula. So y'all, I'm sure y'all have figured out your pay by how much you make and how many hours you work. All right, so next we will look at creating and using graphs of functions. Okay, so similar to what I just did, step one, identify the independent and dependent variables of the function. So I did that. Remember, I did remember that one in real quick. Remember, I said my independent variable was going to be my hours worked. My dependent variable was going to be the amount of my paychecks. All right, so then step two, identify the domain and range. And we did that. Remember, we said, well, our paychecks for our domain, the amount of hours we work, we can't work less than 0 hours. So our domain started at 0. And then we said we could only work up to 40 hours. The company didn't allow for overtime. So my domain was from 0 to 40 hours. My range, we said, would be from 0. If you didn't work any hours, you didn't get no pay. And we said that maxed out at 400 because we was getting paid $10 an hour. So our range had to cover values from 0 to 400. So that's what they're talking about when they want you to identify the domain and range and then use that information for the scales and labels on our graph. So step 3, make a graph using the data. So we did, right? We set up a graph. We made the x-axis, my hours worked. We made the y-axis, the pay, and we plotted those 4 points that it gave us. 0, 0 in the middle. We had 10 and 100 and so on, okay? So that's what they want us to do. Make a graph using that data. And then step 4 was before accepting any predictions, like I could have used that model to predict what I would have got paid for 30 hours. I just using my graph and seeing where my point would have fell on the line, okay? So before accepting any predictions, of the model, be sure to evaluate the data and assumptions from which the from which the model was built. And that's sort of when we came up with our formula. With that formula we had, we said it was 10 times X, where X was the number of hours you worked. So when I put in my 0 hours, I got 0 pay. When I put in for 10 times 10 gave me 100. So they just want you to play with it and make sure it's going to work for your values. All right, so that's the main lecture part of this. So I'm going to go through some of the problems you're going to see in your homework on this section, okay? Yeah, because we got time in here. So I'm going to do homework for 9A. So, question 1. What are the 3 basic ways to represent a function? So remember, we did an example and we used all 3 of these, remember? So we made a table. We made a graph. And we came up with an equation. So a table, graph, and equation are the 3 basic ways to represent a function. All right, so I'm gonna sort of skip around. I want some of the better ones here. So I'm gonna skip to number 4. Because number 2 and 3, just one of those doesn't make sense type questions. So number 4, though, they want us to actually graph. They want us to graph. For A, we're going to call that 3, 1. B will be -8 and 2. C will be 1 and -2. And D will be -2 and 0. Sort of like y'all did on your battleship game, remember? All right, so let me make the graph. So I thought I had a ruler. So I don't guess I got a ruler. So this might look a little crooked here, okay? So I want to make the graph. So that's my x-axis. and my y-axis. So let's see, the biggest point is an 8, so I'm going to make this go 10 each ways. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to go 10 up. To the left side, they're negative. So -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. And then when they go down, they're negative also. So there's -5, -6, -7, -8, -9, -10. So when I plot these points, they want me to put the letter by them because they'll have 4 pictures of one of these answers, okay? So you're going to plot these 4 points on this graph and label them. So A is 3, 1. So remember, they give you the X first and then the Y value for each of them points. X's can go left and right. The Y values go up or down. So for this point 3, 1, I start in the middle and I go right 3. So 1, 2, 3. So at that moment, I'm sitting at 3 on the x-axis until I move in the y direction. The y was a +1. So where you're at on the x-axis, you go up 1. So that gives me my point 3 over and 1 up. So that'll be A. So hopefully this is just bringing back memories for y'all. So this point was -8, 2 for my B. So since the X value is -8, I move left until I get on -8. So there's 5, -6, -7. So there's -8. The Y value is 2. So from that -8 on the X axis, I go up 2 and then I stop. So that went -8 and then 2 up. That is point B. So y'all got any questions on that graphing yet? So it's making sense. X's, negative goes left, positive goes right. On the Y values, positive goes up. And if I get negative, they'll go down. So look, C's got a negative Y value. So we're going to move right 1 for the X value. So starting in the middle, I go 1 right. The Y value is -2. So from that 1 on the X axis, I go down 2 and put my point. So that'll be C. All right, now look at this one. D has a -2, 0. Anytime one of the numbers is a 0, you're going to be on one of them lines. So we start out going left -2 for our X. So we go left 1, left 2. Since the Y value is 0, we stop and stay there. So when the first number's given for the X and the Y value is 0, you're going to be on that line, okay? So that was D. If the first number is 0 and you got a number for the second coordinate for the Y, then it'll be on the other line, okay, or the y-axis. All right, y'all, so that's basically graphing those 4 points, what they're going to want you to do. All right, let me see what we got next. So 5, they want me to write a short statement that expresses a possible relationship. Between the variables. All right, so my variables are giving me are the volume of a gas tank and the cost to fill the tank. So to give you two variables like that, so on this one, we're looking for something like, as the volume of the gas tank increases, the cost to fill the tank increases. So they sort of want us to use a little logic on this, okay? I'm not going to make a gas tank bigger and the cost to fill it decrease, right? So it makes sense that the bigger the tank, the higher the gas, okay? All right, so this one I'm going to show a picture up here. So let me get something behind this here. All right. So they're going to give us a graph. Notice on the bottom of the graph, it says years. And they start at 0, but they're incrementing it from 1950, 1960, 1970, 1980, 1990, and they go up to 2000 on the years. Over here, it says world population in billions. So notice that first one is a little bit above the 2, a little bit above the 3. But remember, this is really 2 billion, 3 billion, 4 billion, and so far, all the way up to a little bit over what looks like 6 billion there, okay? So what they want you to do on this is look at it. The independent variable, well, that's the independent variable on the x-axis. And that's going to be the year. And the dependent variable, which is the y-axis over here, the dependent variable is the population. And they label that year and then world population. Then it's going to ask you, the domain of the function is the years. So our years. And notice, we went from a minimum value of 1950, because that's where my line starts right here, to a maximum value of 2000. Okay, so my domain is those X's going along that bottom. Then y'all, they come in and they said the range, that's this Y values, is the population from the minimum of, so they estimated that to about 2.1. And it went all the way up here to what they use, 6.1 on that. All righty. And see, they're say round to 1 decimal place as needed. So once you label that stuff, then it comes in and says, choose the correct description below. So for mine, I said the function shows a steady increase in population from 1950 to 2000, because this thing is going up. Every one of my years, it steadily goes up. Sometimes it goes up steeper than other times, but overall, it steadily went up. And they're going to have 3 answers that it can't be on those, okay? So look at your little chart, domain, range, put your values in, and then sort of figure out what's happening with that graph, okay? All right, so the same thing happened here. This one says, identify the independent and dependent variables and describe the domain and range. So over here, I said, well, the independent variable is the speed, because that's like your X's. And that's like your Y's. That's like the data table, okay? And it's always got your X's and your Y's. So the speed is your independent variable. Stopping distance was your dependent variable. Okay, the faster you go, it looks like, the longer the stopping distance is. So the domain was my speeds from a minimum value of 10 miles per hour to a maximum value of 70. So you're looking on your data from what numbers your range goes from. So here comes my domain. So here comes my range over here. It was the stopping distance. We had a minimum value of 12, and then we had a maximum value of 316. So we wanted us to look at one of these graphs to model that. So y'all was just sort of looking at it in 10 and 12. I figured it was right in here. 20 and 43. So I made each one of these equal 50 going up that. So that's how they got from 0 to 350. But notice, some of these have bigger distances in between them. So it's not going to be a straight line like that because every one of the distances is not a multiple of that speed. Because from 60 to 70, this thing went up almost 100 feet. Well, from 10 to 20, it's only going up about 30 feet. So your line has to sort of curve a little bit as you're going to the right. So I'm trying to see what was the difference on this one here. Ooh, this one was close. I'm trying to see the differences. Oh, be careful. The differences on B and D, remember, our speed is our independent variable. Our distance was the dependent. This one had them backwards. Although it had the same line, that's what was throwing me off. It had the same line, but they labeled it backwards, okay? Remember, this has to be the x-axis. This values have to be the y-axis. And then on that, and I said the rate at which the stopping distance increases grows faster as the speed increases. Okay, so you're getting a lot greater distances on these faster speeds than you did on these slower speeds. All right, let me see if I got another one. But yeah, we got one more, and I think there's only 8 questions in this homework. All right, so for the function involving the variables listed, which are going to be the weight of the car and the average gas mileage, use your intuition or additional research if necessary to complete parts A through C. So A said describe an appropriate domain and range. So I got to figure out a domain for the weights of these cars and a range for the average gas mileage. So when I look through here, the domain is all average gas mileages of cars. Well, that was wrong. The domain is going to be the weight of the cars. So notice, so D can't be that one either because it's talking about gas mileages. So the domain had to be the weights. So I looked at the car weights. This one had cars weighing between 100 and 800 pounds. Well, y'all, cars can weigh a few tons, which is like 2,000 pounds a ton. So I went with C because it had from 1,000 pounds to 8,000 pounds. I thought that'd be more like the weights of the cars versus 100 pounds to 800, okay? So sort of find one that matches the domain values you think you're going to get. And then it does that on the range. So the range is going to be the average gas mileage. So you can throw out A that's talking about the weights and D is talking about weights. So throw them 2 out. So they had the range is all gas mileages of cars of various weights or 5 to 300 miles per gallon. So Ooh, that's a really low gas mileage at 5 miles per gallon. But what caught me was 300 miles per gallon. I don't know no cars getting 300 miles per gallon. So I looked at C. It was all gas mileages of cars of various weights, or 15 miles per gallon to 35 miles per gallon. So I figured that would fit this data better than the 5 to 300. Now, we know there are some cars that can beat that 35 miles per gallon now. Okay. So, but to fit our data, the one most likely would have been that one. Okay. So now look at these graphs. They're changing them up on you. Although A and B both sort of go down like we need to. Here's my 8,000 and then my 35. This one, remember, they did the wrong one. They did the 300 miles per gallon. So we know it ain't going to be one of them two, okay? And then look, they went from 100 to 800. We needed to go from 1,000 to 8,000. So these were pretty close, other than, remember, the weight of the car. The weight of the car has to be the X value. The miles per gallon is the Y value. And that's what happened here. They just switched them up on you. They put the miles per gallon where the X's should be, and then the weight in pounds where the MPG should be, okay? All right, so then it says, briefly discuss the validity of the graph as a model of the true function. So I said it was actually a valid model because the gas mileage of a car decreases as the weight increases, right? The heavier that car's going, the less that gas mileage is going to be, okay? All right, y'all, so let me see. That was all those problems in that homework. So play with that 9A. It's mainly going to get you used to functions. The next class, we will sort of look at what we call linear functions. And we'll be coming up with equations like that y equals mx plus b I was showing you. So this week we got 9A, 9B, and then y'all gonna be out next week for Thanksgiving. So that'll give you a week to sort of catch up on everything if you're behind on anything. All right, so let me see if y'all have any questions. Now, another thing I'm going to do, I'm going to try to later tonight, is I'm going to try to make a video of me using Excel to do the project for the standard deviation and some of that stuff. I got a few people that were having trouble doing that. But that standard deviation is sort of tricky by hand. So I'm going to try to make a video tonight, and I'll send that out showing y'all how to do all that with your data if you put it into Excel. All righty, so we're going to stop this recording.